Hello students, myself Shashikumar S K from Department of Physics, IDSG College, Chikmagalur. In this session, I am going to discuss about the second experiment of this academic semester, that is series resonance. In the last class, we had discussed about the low pass filter and high pass filter, which is a first experiment. I hope you had understood that experiment and we had discussed in the Zoom class also. In this session, I am going to give the observation and explanation of formula, procedure, apparatus. Therefore, initially the first part of the experiment is to discuss about the aim of the experiment. For that, the aim of series resonance circuit, I think you had been discussing the AC circuits or AC chapter. In that there is a theory part also, that is resonance circuit, series LCR circuit and parallel LCR circuit. Therefore you can understand very easily. The aim of this experiment is to study the resonance frequency of series resonance circuit, as well as by this experiment not only a resonance frequency is going to be determined, but also there will be a determination of the quality factor and inductance of the choke used. You know about a inductor in the PU classes also. What do you mean by inductor or an inductance? Inductance means the property of an electric conductor or a circuit that causes an electromotive force to be generated by change in current flowing, which means a change in current will produce an electromotive force that is known as inductance. The instrument is known as inductor. So that for that, I think in the PU level you had discussed about the self-inductance and mutual inductance also. Therefore you are well familiar with the concept, that is inductance. In this experiment we are going to use a choke as an inductor. ಒಂದು ಚೋಕ್ನ ಇಂಡಕ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ ಅಂತ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಬೈ ಸೀರೀಸ್ ರೆಸೋನೆನ್ಸ್ ಸರ್ಕ್ಯೂಟ್. ದೆನ್ ದ ಕ್ವಾಲಿಟಿ ಫ್ಯಾಕ್ಟರ್ is nothing but the sharpness of the resonance curve is known as quality factor. ಅಂತಂದರೆ ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ನ ಫೈನಲ್ ಅಬ್ಸರ್ವೇಷನನ್ನು ನಾವು ತಗೊಂಡು ಗ್ರಾಫ್ನ ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ you are going to obtain a sharpness, which means a peak value is going to be obtained at a particular frequency. That range is known as sharpness of a curve. That value, sharpness of that resonance curve is known as quality factor. And resonant frequency means a frequency which is going to be at a higher current is going to be flow, that is known as resonant frequency. A current which allows, in a circuit a current is going to be maximum, that is known as resonant frequency. It's going to be takes place at only one particular frequency. We are going to discuss that in later part of this experiment. That is known as resonant frequency. By using this experiment we can determine a resonant frequency, quality factor and inductance of the choke. For this experiment, the apparatus which are going to be used is inductance box, capacitor box, oscillator, then resistor and a connecting wires and other things, and a multimeter. Then the formula which is going to be used in this experiment is for calculation of resonant frequency in a theoretical value is given by F0 is equals to 1 divided by 2 pi root of LC. I repeat, F0 is equals to 1 divided by 2 pi root LC, where L is the inductance of the choke, C is the capacitance of the capacitor, which is going to be calculated. So, resonant frequency is given by 1 divided by 2 pi root LC, so many hertz. Then, the quality factor is going to be determined using two ways, that is, one is from graphical method and another one is by calculation method. That quality factor by graphical method is given by F0 divided by F2 minus F1, which means F0 is the resonant frequency, F2 and F1 are the cutoff frequency. Cutoff frequency we had discussed in the last experiment also, which means maximum gain is divided by root 2, therefore we are going to obtain some value. A graph is going to be bisected, or a graph is going to be cutted by that value. We are going to obtain a frequency. That frequency is known as cutoff frequency. In last experiment nalli ನಾವು ಲೋ ಪಾಸ್ ಫಿಲ್ಟರ್ ಮತ್ತು ಹೈ ಪಾಸ್ ಫಿಲ್ಟರ್ ನಲ್ಲಿ ಸೆಮಿಲಾಗ್ ಗ್ರಾಫ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ. ಅದರಲ್ಲಿ ನಿಮಗೆ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಒಂದೇ ಒಂದು ಸಿಗ್ತಾ ಇತ್ತು. ಬಟ್ ಈ ಒಂದು ವ್ಯಾಲ್ಯೂನಲ್ಲಿ ಅಂದರೆ ಸೀರೀಸ್ ರೆಸೋನೆನ್ಸ್, ಪ್ಯಾರಲಲ್ ರೆಸೋನೆನ್ಸ್ ಎರಡರಲ್ಲೂ ಕೂಡ ನಮಗೆ ಎರಡು ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರುತ್ತೆ. ದೇರ್ಫೋರ್ ಐ ಹ್ಯಾಡ್ ಟೇಕನ್ ದಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಸ್ F2 and F1. F2 and F1 are the cutoff frequencies, and it is also given by F0 divided by BW, which is nothing but bandwidth. The difference in frequency of those two cutoff frequency F1 and F2 is known as bandwidth. Bandwidth is known as a difference in the frequency of two cutoff frequency. Hence its alternate formula is given as F0 divided by bandwidth, BW. By calculation method, it is given by Q is equals to 1 divided by 2 pi F0 CR, where F0 is the resonant frequency, R is the resistance of the experiment. And finally we are going to calculate the inductance of the inductor by using a formula L is equals to 1 divided by 4 pi square F0 square into C, so many Henry. We know that the values of F0 as well as C, therefore by using both theoretical values and experimental values of resonant frequency, almost we are going to obtain a same values of resonant frequency. Hence the values of resonant frequency are going to be placed at this formula. Therefore we are going to obtain the inductance of the choke. For that, let us see a circuit diagram of this experiment which involves, I think you are going to see the circuit diagram in which there will be a different alphabets are going to be used in this circuit, who are CL, RL, where C is the capacitance of the capacitor, L is the inductance, and RL is the load resistance. V0 means output voltage, Vin means input voltage. A variable oscillator is going to be connected. Initially the positive, or usually oscillator positive ಮತ್ತೆ negative ಅಂತ ಹೇಳ್ತೀವಿ. So one end of a oscillator, which is generally a positive end, is connected to capacitor one end, and the another end of the capacitor is connected to inductor. The other end of a inductor is going to be connected in series with the load resistance. The other end of a load resistance is going to be connected again to the other end of a variable oscillator or negative end of an oscillator. Across the resistance, we are going to obtain the output voltage. Before giving an calculating or measuring a output voltage, initially before starting taking readings, we are going to measure the input voltage, or we are going to fix the input voltage for our desired value. Say 1 volt or 2 volt or 5 volt, some value is going to be given that is connected directly to the function generator terminals. Therefore we can able to measure the input voltage which is going to be given to this circuit. I repeat the circuit, that is function generator one end, that is positive end, is connected to capacitor one end. The other end of a capacitor is connected to inductor. The other end of a inductor is connected to resistance. The other end of a resistance is connected to the function generator negative end. Across load resistance, we are going to measure the output by using a digital multimeter. Therefore, an output voltage is going to be drawn across the load resistance. Observations of the experiment is as follows, that is, resistance of a circuit is going to be taken as 1000 ohm, which means in a resistance box we are going to unplug a 1000 ohm and we are going to use a capacitance of capacitor of desired value. In this I am showing a constant one set of values which may be changed for our desired value. An input voltage of 3 volts is going to be connected. We can vary the input voltage of 1 volt or 3 volt or 5 volt or 10 volt. That's based on our instrumental setup. Observation means the values which are going to be decided and keep those standard values in the circuit. Resistance of a circuit is so many ohm and capacitance of a capacitor is again so many microfarad. Input voltage is going to be so many volt. For this we are going to obtain a graph of gain versus frequency is going to be plotted. We are going to obtain a peak value, increase in the gain to certain level after reaching certain value, which means after the increase of frequency it is going to be increases at a particular point, and again further increase in the frequency the gain will going to be starts to reduce. What do I mean by gain then? The value of output to input, that is value of the value of output voltage by input voltage is known as gain. So that when we calculate that gain, we are going to fix the input voltage as a constant value, then we are going to increase the frequency, we are going to obtain the output voltage. Finally we are going to calculate the gain. After calculation of gain, we are going to plot a graph, gain versus frequency. When a frequency is going to be smaller, the gain will starts to increases. As the frequency increases to certain extent, the gain also increases. At a particular frequency, gain is going to be maximum. After a maximum gain obtained at a particular frequency, if we further increase the frequency, then a gain will starts to reduce, which means an output voltage will starts to again becoming a lower value. Therefore, we obtain a lower gain, which resemblance a maximum gain is going to be obtained at a particular frequency that is known as resonant frequency f naught. Maximum gain divided by root 2 will cuts the graph at 2 points. That frequency is known as resonant, that frequencies are known as cutoff frequency. The range of frequency in between f1 to f2, that is known as sharpness of the curve. ಆಗಲೇ ನಿಮಗೆ ಫಾರ್ಮುಲಾನಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ಅಂತ ಹೇಳಿದ್ವಿ. ದಟ್ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ವಾಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಅಬ್ಸರ್ವ್ right now, what we are going to observe right now is going to be a band width. ಈ ರೀಜನ್ ಇಂದ ಈ ರೀಜನ್ ನಲ್ಲಿ ಇರುವಂತಹ ಫ್ರೀಕ್ವೆನ್ಸಿನ ನಾವು ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದೆನ್ further, if we move, we are going to obtain a tabular column. That is, in this experiment, I think we had discussed in the last experiment, we are going to vary a different range of frequencies. But in this experiment, we are going to vary within a certain limit, or we are going to increase in terms of 50 or 100 hertz. Right now I am showing a values of frequency which is going to be increased by only 50 hertz. 50 to nearly 1000 hertz are going to be varied. Then we are going to measure the output voltage. We are going to obtain an gain which is going to be maximum at a particular point. You are going to be observed that is at 350. In this values, we are going to obtain a maximum gain of 0.603. Between or above and below 350, the gain is going to be very or lightly lower. Therefore, resonant frequency as per the values we had been obtained as 350 hertz. If we plot a graph, we are going to take that value as a resonant frequency. Then that resonant frequency is used to calculate the inductance of the inductor. Like this, the experiment is going to be conducted. I think you are cleared with this experiment, the theoretical part. Circuit connections and taking up of values will be discussed in the next class. In this experiment, we are going to obtain the inductance of an inductor, resonant frequency and quality factor by using both graphical method and theoretical method. We know that series resonant circuit is an acceptor circuit. Therefore, there will be a maximum or there will be an increase in values up to resonant frequency, and then the values are going to be reduces. Okay, in this session you are almost cleared with the formulas and taking up of values and nature of graph. In the next session we will continue this class. Thank you.